Hi Florian, how are you doing?
Hi, fine. Thanks for having me.
Now watch this. So the first question is, maybe you remember, what is your first computer?
My first computer. Oh boy, it's a while back. Yeah, it was a Amstrad CPC, or better known as a Schneider CPC in our regions. Um, Nice with a green screen and real old school machine. No hard disk, only floppy disks, and was my first contact with programming languages. A basic interpreter was running on a machine where I could fiddle around with sound, creating a little graphic stuff. And this was my first contact, and yeah, I was, I guess, 12 years or so of age, and yeah, that was my entry in the business, I guess.
This is the abstract companies. It was actually interesting. I will have to do some research because I had a ZX Spectrum 128K, but officially it was bought by Amstrad. So I think with the first release, Amstrad bought it. I think then Amstrad also bought the Schneider, I guess, right? Because
Yeah.
Schneider is a German and Amstrad, I don't know where they're coming from, maybe UK. So we have to do, I will do some research because it's interesting that they bought actually lots of stuff back then. And actually, my ZX Spectrum was a serious machine. The first one was like rubber keys, and mine was actually nice. It was with plastic keys, and and it was a nice machine with integrated data set. So if you got the when you got the Amstrad or CPC, you started immediately programming, or you loaded a game first.
Yeah, of course, it was gaming.
Yeah.
So it was my brother's old machine, actually. I got it from him, or I could use it just for gaming in the first few months or years. But then I discovered, hey, I could do stuff on my own just by hacking some lines of code. There was a huge manual, a few hundred pages with it, with programming instructions, and that's what you could do just by programming. There was no real operating system with an user interface. It was just a console, of course, back then. Yeah, and the first thing I guess was some kind of sound emulator for putting out some 8-bit noises. But I was hooked from the first hour of working with it. Yeah.
You mentioned now no user interface, just a console. What is interesting because to save, you had to type save, and it stored whatever happened on the machine to disk. So I think if we wrote the code, we just used the arrow keys. But how we run it? So I knew there was a run command. I think I know it. You wrote the code, and in my case, there was command R was run, and it ran whatever was on the screen, right?
Yeah, basically, you had to put the line numbers
Sure.
at first, and if you ran out of line numbers, if you didn't leave enough gaps,
Yeah.
you were screwed. So you had to start over again.
Yeah.
So
So I
there was no
10,
way to insert
Yeah,
lines. Yeah.
there was the first pattern was 10, 20, 30, so you had to always never do 1, 2, 3. But if you run the program, you have to specify the line number where it starts. You just could say it run. What I'm interested in, because we wrote the software just in the screen, right? But there was no files first, because to have a file, you have to write it to a tape. What I forgot, how we were able to run the software on the screen, because you had to switch to command mode or something to say run. And what I know on my machine, the R button, I think was just R, was for run. So if I push the button and it ran whatever was on the screen, right? So you know what I mean? Because usually we have an editor, we save the file and we run the file, but there was no files, right? So what interests me, you mentioned this right now, there was just the console, and you're right. So you could write, in the console 10, whatever, 20, 30, 40, 50, and maybe even change it. So there was like the editor all the time. So I think the editor and the console were one, right? There was no editor.
Yeah.
Yeah.
Right. I think it was some F key to start it, F5 or so.
Yeah.
I don't remember, to be honest.
What was my misunderstanding right now? The terminal was the editor. So if you said, let whatever, it is the same as you would just program in Z shell, right? Right now, or in shell. This is what happened back then. So you just wrote, the commands, and they were executed one by one. and you could reset maybe. I don't know how to reset work, but you could run them multiple times. So maybe you should watch on YouTube. There was C64 what they actually did. So this was interesting because there was no editor. I know that you can load the code and save the code, of course, but this was not usual that you save. You have to do. Okay.
Took me a while to figure it out actually, because the stuff I brought was gone after I shut the machine down. So but these were the first steps. And
what is your first program?
Yeah, the sound machine. So you have, of course, I wanted to develop games.
Okay.
Back then, I guess it was some kind of football manager or so. So I hacked in a lot of data, the player names and so on, to build a bit of an initial data set, but I ran out of memory very, very quickly because it only had 64K of RAM. Mm-hmm. And then I had to figure out how to save the disk and so on, and I would have needed, 100 disks to save these huge data set I needed for this game, and then I gave up eventually.
So how many football players are there? I mean,
thousands,
okay.
Tens of thousands.
And you knew them?
I found a data set on some website back then, or not a website. Internet wasn't so far. It was a magazine with, I guess, Kicker or something. Mm-hmm. They had a data set published in their pre-season issue, and that's where I had the data from. But there are a lot of teams and players. I guess in Germany alone there are 20 or 30,000 active players.
Wow.
A million, not just down to the Sunday leagues or amateur players. It's huge.
So your goal was to capture everyone, right?
No, just the pro leagues, but these are a lot as well. So
okay, so you became the Google of German football, right? Okay, that's actually cool. So you were forced to start with a small database, right? Or you think how to offload the memory to persistent disk?
Absolutely, yeah.
Yeah, cool. So what was the next application?
Next application? Yeah, I tried around with later on the X86.
Oh, this was your next machine?
Yeah.
Okay.
I played around with 3D engines actually. With mathematical background, it was back then in my first years as at university, and so I never found a good 3D engine back then which fit the needs. I had a few friends over which were interested as well, and we said, hey, let's make a game, like on a first-person adventure game running around, and you had to render stuff like the Doom engine back then.
Okay.
Kind of this way, yeah. And the engines which were available didn't fit the needs, so I said, let's try it. Make some sprite engines and stuff, and that's where I got into this 3D modeling. But that never didn't go well. So we gave in eventually because it's undoable for a team of 2 or 3 people. Mm-hmm. We realized that really quickly and had to stop the project. But it was a nice stuff to play around.
But it worked somehow, Hello World something or nothing?
Yeah, we had a few scenes rendered.
Okay.
And little sound and camera views were working, or the collision engines actually. Mm-hmm. We had a small collision engine which was working, but after that you had to design all the sprites and sounds and develop a storyboard and so on. So
the last mile.
A lot of work. Last 100 miles. Yeah.
Last 100 miles. And this, you mentioned this was a small team. Was it the university assignment or your friends? Or
no, it's just a private fun project.
Yeah. The Marcus was also hacking with you, Marcus Cat, or?
Oh no, not that early.
Okay.
I met Marcus after university.
Okay.
In different projects. So, but that's I did different projects before I met him. for different customers, just to earn a bit of money for the university. Yeah.
So the 3D was your first serious project at the university, right? So what was the first commercial, maybe, or what happened, and what were the most interesting project you did at the university?
My first commercial project was for the hospitality business, for managing drinks deliveries and storage and so on. Used in restaurants and a few hotels. But then the owner, which paid me, he sold his business, and then the project was dead, unfortunately.
Which programming language you used back then?
Basic, actually.
Basic. So always Basic. Also the 3D engine was in Basic?
Was Basic as well.
Yeah, cool. But it was
Quick Basic back then.
Quick Basic, QBasic. Yeah. Okay, this was the Microsoft Basic, right? I think. Exactly. So, interesting. 3D engine in Basic. So, was it fast enough? I assume it was, right?
Yeah, it ran pretty nicely, on the machines. But these were the last projects in Basic, because Visual Basic later on we used for different projects with other students. I had a project for a little CRM.
Wow.
But it died as well, and because we split ways, we had a different idea. And afterwards I got into Java, of course. So
how you got to Java, from Basic to Java, right?
Yeah. It was taught at university, and I tried out C++ and different other languages, but Java always seemed the most easy one, the most intuitive one for me, and I liked it. And so probably I stayed with Java because I really disliked C++. And that's why I used Java.
Why you disliked C++?
It was too complicated for the stuff I would do. You can do a lot of nice hardware stuff. It's nearer to the hardware layer, of course, but you had to manage everything yourself, the deconstructors or cleaning up the memory and so on. And I said I don't want to do it, and Java does it for me, so I will stick to Java and the freaking pointer and whatever stuff there is.
So I actually have to admit, at the beginning, I really liked C++ because, I could, as you said, I played with constructors, deconstructors, and pointers of pointers. At one point of time, I think how double looks like, and with pointer arithmetic, I could actually see what happens inside. I was fascinated by the entire templates and see in and see out. I like the stream redirections. So I really like it. And if Java came out, I would say, okay, a little bit boring. And what I really hated, there were no header files. So this is what I always search for the .h headers. Where is my .h header? And I say, okay, there's an interface, but somehow it was not clean enough for me because it was the same type. I don't know even. I only remember I didn't like interfaces back then. But I really liked the header files back then. So, and I cannot explain it anymore. what I didn't like about the interfaces, but for me, C++ seemed cleaner, and Java was. Someone told me, this is the next big thing or whatever. This was Oak, and then I said, okay, cool. Then I will look at this, and then I get immediately a project, and then stuck with Java. So there was this short story. And with which Java version you started actually?
It was 1.1.
Wow, very early. So it was like 1998, something like this, right?
Yeah.
Yeah, cool. And at the university, they already teach Java 1.1?
Yeah.
It's a crazy university. Where was Silicon Valley or where?
No, it was a private school near in the north of Bavaria.
Okay, cool.
It's a small town. Yeah, it was a privately funded school back then. Now it's state funded. But I had the luck to get in.
What's the name of the school?
It's in Wiesau. It's a small school with only 50 attendees a year.
So there were Elon Musk, and Jeff Bezos, and then you, right? So
basically, yeah.
This was a cool story actually. And you immediately like Java? Yeah, you said it.
Yeah.
Because it's simple.
Yeah.
Okay. What did you do with Java then?
We quickly went to database programming, actually, attaching or playing around with JDBC or plain SQL back then. And it was my first contact with the relational stuff, of course. No, SQL wasn't a thing back then. There were a few object-oriented databases around.
Exactly.
Don't remember the names.
Echelon is one, right?
Yeah, true. And did a lot of projects because it was the way to go. But I guess you know the story a bit with Marcus later on. In customer projects, we saw it didn't really fit. So we always had the two worlds which were colliding. So tables and the object model, and of course, as a programmer, you like to play with objects. You want to design your object model, but you had to adapt it to the freaking tables and use a lot of features which Java actually has and which would be nice to use. And then we fiddled around enhancing the Hibernate tools and did the stuff back with Repiclips, which was the Eclipse distribution, which we added some plugins to it with UI Builder and the enhanced Hibernate tools to get the synchronization between the object and database side better going. But we always saw, it wasn't the way to go. You will always have the same problems. We could ease the pain, but we couldn't heal the problem. Yeah.
You played with JDBC because you still had the problem with the football players, right? So you still wanted to solve it? No.
It was a way back.
I think this was
bad idea. Yeah.
Your trauma, as a kid. I have really to store all the football or soccer players.
It was in text files back then.
Yeah, the JDBC. So what I remember, because I searched now, I remember Echelon, but they renamed the thing to Echelon at a nicer name. There were lots of object-oriented databases back then, and after that, XML databases came. And in every project, I had to evaluate a couple of object relational databases and also XML databases. It was huge hype because back then, no one believed that SQL will survive, right? This was the thing. So in every project, it's like, we cannot use SQL because it will die. The future are object databases and XML databases. And this is why we started, back then with all the patterns, DAOs or whatever, because we said, okay, we have to decouple from SQL because, these were my clients, actually. I just would say, okay, you have Oracle, but they say, okay, no, the future is something different. And even if you look at the early J2E patterns, they also stated, there is a lots of persistence, file persistence, object persistence, XML persistence, and therefore we need a DAO. So, okay, then you have the DAO. But you play with JDBC, and then you immediately started to use Java commercially, or you did some research, and then you met Marcus, or how you met Marcus, maybe.
I met him while I was in Visa. So he had an offering for an internship, and in a very old company back then, he had with different partners. So they did a web editor, like a bit like front page or a PowerPoint, and I really liked the idea. So I said, I took the internship, and so I met him and the crew and the project, and that's basically I worked together with Marcus since then. It was 2001, over 20 years. Yeah.
Okay, and to the listeners, we had a couple of episodes already with Marcus Cat, and the last one was 116, when a Java application becomes a DB, for instance. It was about the MicroStream. Okay, and so you play a little bit with Java, then met Marcus, and immediately started to use Java commercially, more or less commercially with him.
Because they use Java as well, exclusively, and so I really focused on this language. I threw away all my C++ basic stuff, and
Okay, so what do you build, or how long it took, or what happened at Marcus' company?
Yeah, we built the web editor wasn't finished yet, so I joined the team afterwards. After university, he gave me a contract, and I joined the team and immediately added features to this web editor. And afterwards, so web editor was running well, had a lot of users, because it was distributed over magazines back then and service providers, internet service providers. But there was always customers said, yeah, we have to customize stuff, we have to add features like online shops and so on. This was always the wish of a lot of customers, and so we planned around and we went in a different direction. So the idea for a little development environment with a web front end was born, and in the first versions we designed kind of a basic dialect, because the guys which wanted to develop stuff for their websites or online shops, they weren't programmers, they were designers. And if we would have used Java for this, they couldn't have made any stuff. So we had a really simple basic as a backend language. And this worked for a few solutions, but it wasn't powerful enough. And you didn't have an ecosystem, of course. There were no libraries which you could use. And we had to add all the features developers eventually need, like version management or a proper IDE. This was not the way to go. We realized after a few months or 1 or 2 years. And that's why we decided to move the IDE to the Eclipse platform, to the Eclipse IDE, use all the existing stuff like the Subversion, or Git wasn't a thing back then, or not a popular thing.
Yeah.
So we used Subversion all the time, and all the proper development tools which we couldn't provide because we had just too small of a team. And that's why we decided to move the project to the Eclipse Foundation and eventually use Java as a programming language for it. Because we said even if a few designers just develop the frontend, they can use these real programmers for it, or buy software, because Java had a bigger ecosystem back then. So you have all the libraries you need, all the tooling you need for monitoring and whatnot. So we decided to move to Java eventually, ditch the basic stuff. And so we had a quite powerful IDE.
To Java as design language for the front end, right? So at the beginning you tried to be a no-code, and then
low-code stuff.
And then you say, okay, the Java is too powerful, so let's allow Java to be used in the front end, because in the back end everything was 100% Java all the time, right?
Yeah.
You also focus on server, or was it a fat client back then?
It was a server application. Yeah.
Oh, which application server, or you built it?
It was we used Tomcat most of the time. Yeah, Tomcat.
And in the front end, you connected to Tomcat via SOAP, or?
It was a Warden application.
Ah, okay. From the beginning?
Not from the beginning, but after we moved to the Eclipse platform, we decided to use Warden.
Okay.
We played around with different stuff, different frameworks, but Warden really made the race between the frameworks, and it was the best.
Yeah, and it looks beautiful as well, right? So nice people, looks beautiful, good open source strategy. Yeah, it was the right choice. When was this with Warden? Which year, roughly?
That's a good question. 1 or 2 years later, we met the guys at the Java 1. I think it was in 2006 or 7. Yeah.
Okay, so it was really early. Because before that, I think the Google WebToolkit happened as well, right? But it was terrible. So I mean,
Vaadin used it in the first versions. Yeah.
But Vaadin used it even later. But they hide it, right? So there was no reason to create the compilations. Or the genius thing about Vaadin was that Vaadin precompiled all the components. So it was really fast. And if you use GWT directly, it happened all the time in the hosted mode. So it was very slow and terrible, actually.
Yeah, true. And that's why they decided to ditch it and use web components instead. Yeah.
Oh, this was the reason. Yeah, web components even better, right? Because
Jonas, the founder, one of the founders, that he sees web components as the future in web design, which he was right about, and that's why they decided to ditch Google Web Toolkit and use different tools under the hood and go completely to web components, and they split the framework, so you can use web components and JavaScript only on a client side, and they attached the server-side framework to it. So it was the right decision in my eyes as well.
Yeah, it was an excellent decision because I already used Vaadin in my web component only project. So if I need some custom elements, Vaadin is one of my first choices. So they have really nice components. Calendar one, of course, table. So looks nice.
And charts and so on.
Yeah. Yeah, nice. So I didn't knew that it was that early that he used Vaadin. And what's also interesting, so maybe we are 100 kilometers apart, and I never met you actually earlier. So this is the crazy stuff, because I was also in the Java community and know actually most of the people so active in Germany. But you were the closest to me, and I had no idea that something like this happening. So I didn't knew Marcus, I didn't knew you, and we both did Java. So this was actually, you were somehow hidden, in the Bavarian forest, as I always say. And I spent also sometimes at conferences, but I was not aware of actually such interesting projects in my neighborhood almost.
Yeah, that's odd that we didn't meet earlier, because we went to the systems conference back then, and mostly CeBIT, in Hanover.
Yeah. I was also CeBIT and systems, and both conferences were really big. Big means at the systems there was a traffic jam, and at the CeBIT even worse. I would remember they had to change the lanes on the street. In the morning, it's like everyone goes to one direction and only one lane back, and then they change it, they flip that. So
they changed the autobahn to a one-way street basically.
To manage the traffic. And I also was on the CeBIT, and I was on the systems and I had similar project to yours actually. It was a content management system as well, built from scratch, but it ran on Java web server, but it was earlier. So I think I stopped there in 2002, and this was a larger project. I was contractor, and it was servlets, basically Java beans, not enterprise Java beans. They were not. I didn't like them at the beginning, so it was also no need. So we used Java beans, servlets, and own transactions. So and we built a small design tool as well with Swing, and how it worked differently. So we serialized Java beans as a templates, and we could read the Java beans into the front end and use the parameters into the template. So it worked a little bit similar to CSS right now, I think. So exactly, the Java beans was like a CSS file more or less, and it worked well. So now this would be unusable because it's well too complicated. But for back then, the Swing design, you could actually say. The font size or whatever, it was like a table. So we built a small designer which serialized the Java beans, and they were loaded at runtime to the system. I even think from database, it was always Oracle. And so I was a little bit earlier, 3 years, and then I spent lots of time in consulting, so in different projects. So this is where it was a little bit more chaotic. Okay, so what happened after the editor? You always worked with Marcus since then?
Basically, yeah. So afterward, the editor we saw in customer projects or the users of the IDE, they really liked the designer. They built beautiful user interfaces, but they had always trouble connecting to a database. They fought with Hibernate sessions and caching and settings, and it was a mess. And we saw in our in the customer projects, or the feedback was it's too complicated. We don't like object relational mapping. Databases are fine, but the conversion is hard to do. This was mostly the biggest problem, and we didn't like it anyway. So basically the idea was born. We had to go a different way, a different path regarding persistence. So
your server used at the beginning Hibernate or JPA? Hibernate plain, right?
We used JPA, but
with Hibernate.
With Hibernate, yeah, we never used different framework.
Yeah, okay. And then of course there's how to call it, the object Java object relational gap, right? Because objects are not tables, and you cannot do it right, because if you normalize a table, the Java objects are to fine grade, and you spend lots of time joining, so it is really, really slow. And if you denormalize the tables, it looks right from the Java perspective, but back then it was mission impossible, because every database administrator will try, to revert that. So it was actually, in my projects, we had a couple of one-to-one tables, so one-to-one relation, right? And I wanted to merge them. And this was like, I already knew 3 hours discussion in meetings. So you cannot do this. You denormalize the database. And now, surprisingly, we can just do it, and no one cares anymore, right? Because the storage is cheaper than back then.
Absolutely, yeah. And the problem was a lot of old databases were used in the projects, and a lot of tables were documented, what field does what, and so on. It was a mess. Nobody wanted to touch the database anyway. Just add new stuff, but never touch the old stuff. Don't change it. And so they had to adapt to the existing database, and it was never easy to get it halfway decent, fast to work with a Java application. We had always a problem with performance. And it was complicated. The queries, we had queries over 3 displays or 120 lines of SQL code. It was horrible, yeah. So and that's where the idea was born, to say, why do we need a database in the first place? So we said we all like Java, and all Java programmers can design the object model based on the business problem, without thinking persistence in the first place, but then you have to adapt it to a database. So they did it the other way around. So they designed the database and then imported the object model with the Hibernate tools most of the time. And so the use of the Java features were very limited, because you couldn't use maps properly, and complex types were hard to use anyway. And if you added different frameworks like monetary APIs or data APIs, it was impossible, because you had to write your own converters for JPA and so on. It was a mess, really hard to use. And you still had the impedance mismatch and the 1,000 other mismatches to handle. And so we said Java can do everything except persistence. And that was a missing feature for us. Of course, we had JPA, but with the known problems. And so we decided, or said, there must be a better way. And said the Java application is a server anyway. So why do we need a second server just to persist data? You can do all the stuff like user management, write management, and so on in your server application. You have a central point where you can do it. So let's just add persistence to the server, and you should be good to go. And that's where the idea of MicroStream was born, or JetStream we called it back then, internally. And
I actually know the JetStream name back then.
Yeah.
And when it started with the JetStream, so the very first idea, which year was it?
It was about 2013, 2014.
Okay.
Yeah, the idea was born, and we said, so in order to store Java objects, you have to convert them to some format. So there were XML parser back then and the Java serializer. So we said, XML is too slow and it's too much overhead. So we have to go to binary form, and the Java serializer was no good, or is no good. So
back then, how you found out that the Java serialization is not good? So I mean, you knew it, or you had a real problem?
Yeah, the biggest problem actually was we didn't want to just snapshot the state of the JVM because it was too slow for huge data sets, or you couldn't handle bigger amounts of data with small amounts of RAM. So the snapshots were out. And then we said we had to store and restore parts of the object graph, and we had to use lazy loading and unload stuff again to free up the memory, because you have to handle hundreds of gigabytes of data with small amounts of RAM. So with a Java serializer, it wasn't doable, because you always got object copies and new object references which we couldn't assign back to the object graph.
So the problem you got is if you have no references between Java objects and you serialize the first one, everything gets serialized. But what you needed is that you have a serializer which is a little bit more configurable, so you can say serialize just this one and later the other one, and then you can load both and reconstruct them in memory, right? This was the missing feature from Java serializer.
Absolutely. Missing feature. And another thing which wasn't good, the objects have to implement the serializable interface in order to be serialized. And back then we thought there are a lot of libraries out there which could be used to solve several problems in business applications, and they weren't serialized. So you couldn't use them. And that was one feature, and the security issues as well, because most of the security issues with Java were caused by the Java serializer. And if we would market a product, would use a product which has a lot of security flaws, nobody would use it.
Yeah. And can you briefly explain, by the way, before you briefly explain, I just thought about your design decision to say we don't need the server, we can load everything, we can store everything by ourselves. Similar decision made Apple, right? There was a product, I don't know whether they're aware of it, called FileMaker. It's still around, and they are hugely successful, and they have similar idea that they are very efficient with storing the data. And actually, I met someone who is not, I forgot who it was, but is not a programmer, not a software engineer, and he created amazing application with FileMaker, really amazing, and had no idea about SQL, right? So this is actually an interesting decision. This is what I would tell you, and I just forgot the name. This is FileMaker. Yep. So now, how we could use, so what is the simplest possible hack for Java serialization? Let's say I would like to have a Hello World app, and I would like to hack it. So how to tackle that?
Yeah, it wasn't so easy to do. In order to hack it, you had to inject malicious code of some sort, because the constructor code was called back then in a serializer. They fixed it with newer versions, where you can whitelist or blacklist classes. There were hacks done to Struts servers, which used the serialization internally and also with Apache common types. So you could really inject code into running application servers, and it was an exploit which was used, unfortunately, in huge applications and caused a lot of damage.
Yeah, there are lots of applications that used the commons collection, right? And the commons collection serialization, and if you knew that, you could inject code which was executed, and you could call...
Right.
Exactly.
Yeah.
So it's not that easy, but it's possible. I mean, if the target is big, we could do this. So what we have to do is we have to manipulate the serialized messages on the fly, right?
Yeah. Or you could shut down the server. There was an example with nested collections, which referenced back to the root, and this crashes the serializer because of a bug in the collections. So if you put a data set with this special collection constellation in the server, you can crash the JVM because of an guess it was I think he ran in an out of memory area because he
or stack
or a Stack Overflow.
Yeah.
It was a Stack Overflow. You know, yeah. It so he could crash the JVM and bring the server down with a simple hack. Just add a few collections, put it in a data packet, and send it to the server as a payload, and the server goes down. Yeah.
So why now the Jetstream or MicroStream serializer is unhackable or harder to hack?
Yeah, we do use a different approach at the deserialization session stage. We don't execute code at all, so that's not possible to inject code and run it at the deserialization phase.
What are you doing then?
We just use low-level stuff in a JVM, and we reserve address space in the RAM, which is then linked to a reference or an object, and then we populate the data directly byte by byte in RAM for the fields. And then we say the JVM there is a new object, and it just assigns the object range to this reference, and the object is born in a low-level way. And that's safe to do. No code is executed, and of course the quickest way.
What did you say? It has to be, if you do it right, it should be actually the fastest way, because lets me so the problem with the Java serialization was it is kind of an interpreter, right? So there is the object message which travels over the the serialization binary which travels, and there is the object input stream. I always confuse them, and there's the method read object. And if you read object, the serialized object is deserialized, and basically back then, the methods were invoked, the list constructor, and there was some specific magic. I think it was allowed, to set directly private fields, which were usually not allowed, but the serializer could do that back then, right?
Some magic method, read and write object.
Yeah, exactly.
And the constructor was called, and the static the initializer blocks.
Yeah, and what you are doing, you say, okay, I'm not instantiating Java objects, but I'm creating on the fly the object in memory, and I say, tell the JVM, now use it.
Yeah, we asked the JVM to reserve space on a heap for a new object, get the address back, and based on that address, we can write directly to the memory and populate the fields, because we can get the offsets of the fields relative to the object's address with the low-level stuff like unsafe and so on. Yeah, that's or unsafe is one of the low-level stuff in the JDK.
Sun, misc, unsafe.
Sun, misc, unsafe. Yeah. Interestingly, there were a lot of discussions at the Java 1 back then, because they wanted to get rid of it.
Exactly.
But a lot of popular frameworks used unsafe, and so they couldn't kill it. But they are moving a lot of unsafe stuff to the public API space, and that's the way to go in my eyes, to offer low-level stuff for Java users as well.
Yeah, sure. Of course. I mean, if there's some machine learning or whatever, it's always low-level stuff, so they have to allow it. Otherwise, maybe with Project Panama or whatever would be a little bit easier. I don't know, but yeah. So you basically are not using GNI. You just fully rely on unsafe, right?
Yeah.
No GNI. But this is actually pretty cool idea, but I would say the idea is crazy. This is why no one is doing this, because it's hard. But if you do it correctly, it is fast and safe. Unless someone replaces your deserializer, right? Because then this is unsafe again. Because if you have access to the deserializer, you could do whatever you like if you understand the code, right?
Yeah, of course, but you have to change the actual application.
Yeah, exactly. Yeah, I mean, it's always true, right? So even if I serialize the object correctly, I can still change the applications to do some stuff afterwards. So this is like doesn't
a general problem of serializing data without ever framework.
Yeah. So I'm really amazed, because I had to know always, I ask Marcus about what's the thing, and I say, okay, we are fast. I was okay. Everyone claims you're fast, but now I understand why you are fast, because you are just streaming the classes directly to native memory of JVM and say, now use it. This is like, the double buffering, back then with Amstrad, right? Almost back then with the pictures. So,
yeah.
So, cool. So the serializer makes absolute sense. for me. Okay, but it was not enough, right? So you say, okay, serialization is one thing, and I always, interested in the serializer, but you say, okay, this is not about the serializer, we have more. So Jetstream was the serializer, or it was already the small database you had?
It was a small database, so consisted of 2 layers. The one was the persistence layer, which was the serializer. It was able to what we did was assign unique IDs to objects internally. And so we were able to restore parts of the object graph back to the live one, and so we could do lazy loading and unloading stuff and manage bigger amounts of memory with smaller amounts of RAM. This was the key point, because we did the swizzling internally. Swizzling is the technique for assigning unique IDs to objects. There's a Wikipedia article for it, actually. It's just a object ID relation management, and because we can do it internally with our own serializer, we could manage the partial loading and unloading of the object graph, and that's what a database should do, not just snapshotting the whole state of the RAM, but storing and restoring parts. And
the dirty parts, right?
The dirty parts.
Okay. And you call it swizzling. The swizzling is a technique to partially load and unload. Is this called?
Swizzling is the mapping from ID to the object. It's an official term, actually. Yeah.
Okay. And the swizzling was, serialization plus swizzling is the database.
Yeah, it's the binary data we construct and restore. So that is the persistence part. On top of that, there is the storage layer. So the users don't want to manage files by themselves, because you have to write the binary data somewhere and restore it somewhere. And the thing is, if you change your objects and store them again, you got obsolete data in your data storage. Or if you delete objects, let's say, or so you dereference objects, so the object gets collected by the garbage collector in the RAM, it has to be removed from the database as well. Otherwise, it would grow indefinitely, the binary storage. And that's what the database layer does, or that storage layer. It has a housekeeping process running in the background, defragmenting the binary layer. It has a garbage collector running on the binary layer, cleaning up the old stuff. And we have a so-called abstract file system where connect the binary target.
Question.
In most cases, just a local file system.
The file system from JDK, because there is a file system provider, so you use this from JDK or your own. You could create your own file system.
We have our own, but we have an adapter for the NIO.
Yeah, that's what I meant.
Yeah.
This is cool. Yeah. So that's the first example of I know which uses actually the file system provider API from NIO.
Yeah, we have the first adapter we did, of course, was for NIO. Most of the applications just write to a local or mounted disk. But in a cloud, people wanted to write to different storage targets like S3 at AWS or Google Cloud Storage and whatever they are called.
Wait a second.
So,
one question, because I got immediate an idea. You mentioned cloud. So with would it be doable? Let's imagine I have a Java object is called picture with metadata, and this picture has one-to-one relation to attachment, which is the actual picture. So could I use MicroStream and say, store the picture metadata in DynamoDB, but the binary data in S3?
Yeah, you could. We have adapters for S3 and DynamoDB.
Yeah. But what it for? I know that you have the adapters, but the thing is, whether a MicroStream is able to load one object graph from different stores.
Yeah, you can do it.
But this is one of the killer features, right? Because usually you always would like to have fast access and maybe even better search for metadata, but you don't like to store big images or whatever in the same database. So usually you would like to store it in S3. So this would be actually a nice example, to split it, to have the metadata
absolutely
in Aurora or DynamoDB, And this would be a really because this is undoable, or I mean hardly doable with Java serialization. What I will have if I would use Java serialization, I would use two different object like Java records, load them independently, and then create my own domain object which knows the objects and reconstructs the links, right? So I will have to double the effort. So it would not be transparent. But with MicroStream, what I understood, you could use the same objects and just configure MicroStream and say attachment goes to S3 and metadata goes to DynamoDB, right?
Probably, yeah. What you can do is you can use different storage managers or multiple storage managers in a single JVM. And one storage manager has several root objects and can write to different file targets. So you can make one subgraph which writes to a DynamoDB, and the second subgraph with raw data, for example, goes to S3. Or the more easier way would be to have just some metadata in your object graph, in your live graph, and just link with a unique ID or a name to the binary data and put the binary data just in S3 blobs and load them by hand, because these are blobs, so it's just a single call to load it.
Yeah, sure. This is what I can always do, but if it could be transparent, it would be interesting, because I could just have my Java object graph and then later decide where parts are stored.
Yeah. You can customize it down to the last byte. So if you want to write, let's say, an handler for images, the handler is responsible for storing and restoring a single type. So I write a handler for image, and the handler serializes and deserializes the object. And it could do it in that way that the serializer goes for the metadata, and the binary data is just attached to a different storage target.
Yeah, even crazier. So what you're saying now, we have one Java object with it's just picture, and it has 5 fields or strings or whatever and ints, and this is stored in DynamoDB. And there's one field byte array, and I can now configure it and say the byte array has to be fetched from S3, right, in one object.
Yep.
Yeah, this is even better. Because in my solution, it is already pre-assuming that you need a reference between two Java objects. And the second, what you suggested, I like it more, because you have one Java object and the parts of the Java object are stored in different data stores, which is really cloud native. Because you could even pick and choose depending on costs or whatever, right? You can say, okay, I get S3 is cheaper. Yeah, it's all about cost in the cloud.
Yeah, or just you can do it more easily. So you just write a lazy getter for the get binary data in the image in your Pojo, and just make a simple call to S3.
Yeah, but then I don't need MicroStream,
That's true.
So I'm just thinking about transparency. So if I really go full in MicroStream, then I would like to have a very clean Java Pojo domain object, and then use the MicroStream configuration to tell it the byte array ships from S3, and do it outside. So this would be one possible approach.
Absolutely,
so the cleanest one. Yeah. And how flexible am I with the IDs? Can I just have my own ID provider, or I have to use for the objects?
Oh, you don't need to use own ID providers. It's managed transparently in the background, so you could access or could query the object IDs, which are just increasing long values, but you never actually need to deal with them. It's done in a background by MicroStream, and the reattachment to the live graph, the reassignment of the references, is done by the serialization engine. So you don't have to fiddle around with this low-level technical stuff. And what you also don't need anymore are stuff like primary keys, foreign keys, and so on. So think of the past. Just use your Pojos, your object graph, in Java like you're used to, without a persistence in the background, and then add MicroStream and say store and load, and that's it. Don't have to worry about the technical details anymore, like with object relational mappers.
Why I'm asking, but I have to access the first object somehow, the root object, and for that I would need the ID, right, of the object.
No, you just call root of the storage manager or get root, and he knows because you set the root in the first place when you initialize the database, the initial data set, and then the storage engine knows what object is assigned as root, and you get it at the next startup. You don't have to know the IDs. Yeah.
So there is only one root then.
You could use multiple roots. You can inject multiple root managers. Well, there's a root manager in the background because we have to manage multiple roots. For example, constants, Java constants. We have to deal with as roots. It's transparent in an object model as well, so you don't have to worry about it. You can manage several roots by yourself. But what we suggest is just design a root object. Pojo and split from there. Yeah. So you can handle it in your object model and don't have to fiddle around with the low-level stuff of the persistence engine.
Yeah, what I just thought about immediately is, okay, what I could do is I could have, a part of my data stored in database, in a table. And then if I would have the MicroStream IDs, maybe I can just do later something, right? So I can look up then my root with the ID and then get it back. But
you could, if you have an use case for that, you can query the roots of the objects of which MicroStream uses internally.
Yeah. And then was the next question, because I had the problem recently, is what it would be nice is the question about IDs, to make the ID swappable, because there is an algorithm called ULIDs, and they are time sortable. This is like UID, and what is prepended to the UID is the timestamp. And this is pretty cool, because if you have an application with heavy load, you can actually say, okay, what was the most recent UID? It's still UID, but it is at least sortable, right? So this is why I ask whether it would be possible to swap. But there's no use case, just to know. I was curious because I had a problem recently.
No, we don't use timestamps internally. It's just a increased long value.
Yeah, then this is sortable anyway.
And it's by time, because the higher the UID, the newer the object.
Yeah, this is even better. This is what I thought. So I mean, this is what I needed, because if a UID is not sortable, but if your is sortable, it's pretty nice, because you put the ID somewhere, and they say, okay, sort by whatever. So sort just how is it called? Lexicographically sorted. And then the newest or the oldest, they appear first. This is what's nice about UIDs. But if yours is long, it is already the case that the ID is sortable, which was actually the question. Okay, so my understanding, 2 layers. So Serializer is able to load parts of the objects, dirty detection, and is able to store parts of the objects. Then it also streams the changes directly to the JVM, deserialization, and how deserialization happens actually. But deserialization we covered, but what about the serialization? So what are you doing there?
Yeah, first of all, we have to analyze the object by reflection, which fields should be stored. You can exclude it by default is a transient keyword, like in a Java serialization. And based on the reflection, we create a metadata where the object information is stored. And based on this layout, we stream the data from the RAM to the binary storage. So we just read the values directly out of the RAM. We don't call getters or use reflection to eject field data. We just traverse the heap directly with low-level memory stuff and get the values out. And that's how the serialization works. What you can do as well is versioning of classes. So you can change your classes over the lifespan of your application. You have to do, of course, because you want to release newer versions. And we call it legacy type mapping internally, so you can map from one version of an object to another version. Let's say you split name into first and last name, or you change a string to an int, and so on. And that's what the serializer can do as well, or the deserializer. That's embedded in a serializer itself. It can manage different versions of objects.
So serialization is not, I would say, not that revolutionary. I mean, you cannot do something different. It's just, straight, reflection. So it is. So I think your magic is the deserialization, right? This is where your advantage is, and yeah, I would say amazing. So if you like, I could re-invite you back, to talk about more Eclipse storage and more deeply about how to search for objects and playing with streams, Java streams, and stuff like that. But where people can find MicroStream, you're on Twitter if you have questions,
Yeah, of course, MicroStream is on Twitter, we are on LinkedIn, on GitHub.
Mm-hmm.
The best way to get involved is at the GitHub discussions.
Mm-hmm.
Just Google for MicroStream, and the first few pages will be our website and the GitHub.
And you're also on Twitter or somewhere?
Yeah.
I will put it to the show notes. And do you also active on Discord in MicroStream or?
Not on Discord, we are on Slack.
Mm-hmm.
I can send you the information. And Slack, GitHub, and Twitter.
Yeah, but GitHub discussions and Twitter is just fine.
And, yeah.
Thank you. It was really interesting discussion. So about MicroStream. Oh, it's of course open source. We didn't mention that, right? So everything is open source. So,
yeah, it is.
Yeah, everyone is invited to contribute, hopefully. And yeah. So I would say thank you and see you next time.
Yeah, thank you for having me.